Good morning. My name is Jake Kurth. I'm with Leeds Forensic Systems. Thank you for tuning in to our live stream. This whole COVID thing is new for us, as well as all of you and all of our customers. So we really appreciate you spending some of the time of your work from home to come to our Leeds Spectral Vision training. So this live stream is going to be a couple things. It's going to be, there's going to be a PowerPoint. We're going to go through, a lot of you are already familiar with this, but just kind of as a grounding point, on just going through what is fluorescence, how does it work, and how do you, in general, how do forensics exploit it, but then how can you really use the LSV2 system to be able to exploit fluorescence and be able to find those semen stains, or what I call the Where's Waldo of forensic biology. We'll also go into those topics about how does the head move, some tips on there. As several of you have already discovered, there is a chat window, which is one of the nice things with YouTube streaming. It allows us to get you very high quality footage and audio, but at the same time, there is the ability to still have some back and forth. So as we're doing this live stream, if you have any questions or if there's something you would like me to elaborate on more, feel free to type your question in that little chat window, and then I'll check in from time to time and address those questions. Okay, there you go. Thank you for your interest in our digital workshop. This is the LSV2 system, as you can see behind me. The idea is that we've combined an imaging head onto this long articulated arm, along with a computer and software built into it. And the whole concept there is it allows you to very easily screen over your evidence on your table and then document while you're doing that. And the goal is ease of use and quickly moving. This is just my general goals of this workshop, is to really provide you guys the overall. In your neighborhood, something to just put out there is that there are about 20 LSV2 systems in the entire state of California at 19 different laboratories. So a lot of the DOJ labs, I think all of the DNA DOJ labs have them, but then there are additional systems throughout. So like, for example, San Francisco has 2 LSV systems. I just like to tell you this because there is a network that's available for you to use and to connect with outside of just Cal DOJ, but then also the county labs and other labs nearby. Broader-wise, we know forensics is a very small community. So this is just a snapshot of all of the LSV2 systems we have installed in, it says here US, but it's United States and Canada. We also have some resources available, specifically our training videos, which are on YouTube, as well as our recommended filters and lights posters. But what I've done is I've posted in the live chat 2 different posters that we've made. And again, these posters just give you kind of an overview, where the system works, how does it work, and then some light and filter guides. Fluorescence, what is it? So fluorescence applications, the whole goal of it is to bring contrast to samples that have little to no contrast themselves. So for example, that white semen stain on a white piece of fabric, or that dark blood stain on a dark piece of fabric. The idea is to just try to amplify that contrast. The purest form is it's just a contrast technique. And what's kind of interesting is the way it works is because it's causing a light point to shine back at you, you can actually detect things that are below the optical limit of both your eye and also whatever it is you're imaging with. So the idea with forensics is that biological stains fluoresce. A lot of them fluoresce. Whether it's a semen stain, a vaginal secretion, saliva, most things are going to fluoresce. The downside, though, is, as you undoubtedly know, many dyes, fabric brighteners, things like that, they also fluoresce. I like to show this slide just to give a sanity check of where we're working in the electromagnetic spectrum. So for the LSV system, for all ALS imaging, we're really working just in the visible spectrum. The idea is you go from 400 nanometers basically all the way up to 700 nanometers. And the higher the wavelength, or the larger the wavelength number, the less energetic it is. And we'll go into that more, but basically, Roy G. Biv, but backwards. I like to use this example of fluorescence to talk about it because there's these devices called signal mirrors. And it's a good analogy to fluorescence because both of these techniques are about increasing contrast. So a signal mirror, for example, is a mirror. It's a survival mirror. You'll use it to signal over long distances. The idea is I think the human eye has a drop in resolution of maybe beyond 10 miles. But with a signal mirror, because you're directly reflecting the sunlight back into an observer's eyes, you can cause a massive increase between contrast between you and your surroundings. And up to 50 miles, I think, is what I reference here. So in this particular example, we have a picture that I found in Google, and it shows that there are two people on this cliff, and one of them has a signal mirror and is reflecting it back, and the other does not. And this is a great way just to show that by being a point light source, by shining light back, there's that huge increase in contrast, and you can very easily pick out that individual from their background. It's the same thing with fluorescence, in effect. So here's a slide I put together. It's my crude drawing slide, a schematic drawing of fluorescence and how does it work. So the idea is when you shine a high energy, so those are more shifted, well, pretty much you can do it anywhere along the spectrum, but let's in this case use a high energy shifted toward the violet side, so it's going to be blue energy, blue wavelength of light, comes and hits the molecules that are going to fluoresce. Their electrons bump up to a higher energy state. And then over time, there's some other things that happen, but eventually what's going to happen is those electrons are going to drop to their basal energy state. And when they do that, for the most part, they're going to emit a lower energy wavelength emission, so of a photon. So blue light comes in, the electrons get excited, and when they drop back down to their basal state, they release a lower energy, a more red-shifted wavelength of light. There's some other really cool things. This is what's called a Stokes shift. There are this little section that I just skipped over where I said other things happen. That's where things like anti-Stokes shifts can happen. So there's a whole lot of really interesting stuff that might have forensic applications in that region. But for ALS, this is primarily the schematic that you're interested in. So then we go to our next slide, which is about how does it fit for forensics. So we shine our blue wavelength of light at our semen stain or suspected stain. The stain fluoresces. The extra blue light gets reflected back. And then what we do is we put an orange barrier filter, or in like using goggles, you put the orange goggles in the middle of your light path, and that filters out everything that you're not interested in. So it filters out all that blue light. And so you end up, here's a picture of white light, and then here's the same picture just underneath different excitation with that blue light. A quick note here, just to quickly point out, when we're using the ALS system or any ALS system, including the LSV, while we can image it, we won't necessarily be able to tell what it is. And so we always recommend doing a presumptive or confirmatory test afterwards. That's the idea, and that's ideally what you want. So here's our schematic again. We have our blue wavelength of light shining down at the sample in our electromagnetic spectrum, and then we have our sample emitting, and we've got that filter loaded right in front of our sample emission. And the idea there is that it filters everything out other than our sample. And so all we're left with are these glorious, beautiful stains that we can then image, we can search, we can write up, and then move on. The downside, though, is that background often has a similar profile, and it can be sometimes brighter than the stain you're working with. And that's really where it comes down to about ALS screening, is trying to make a difference between the background that the sample is sitting on and then the sample itself. And there are numerous ways to do it. For example, chemical tests. It causes blood or heme to glow. That's designed to cause an increase between the sample. You can do antibodies that are specific to a stain. The nice thing is, with ALS work, there is also the ability to try different wavelengths of light and different filters to try to cause that bigger difference. So for example, here, because we had that schematic example, we had a lot of background that was very similar to our sample. What happens if we change our wavelength of light? So we change it from blue to violet, just to see what happens. So in this case, in this example, our sample still emits in the orange spectrum, and our background is now fluorescing green. And that just came from changing our excitation source, our wavelength that we're shining down from blue to violet, and it caused the difference between the emission between the background and the sample. And so in this case, our orange filter continues to work. That's ideal, but the reality is that fluorescent samples or biological samples fluoresce broadly. And so it's not as specific as this example. It's not like semen only fluoresces at 570 nanometers and is a peak just right there. The reality is that it's pretty broad when you hit it with a high energy wavelength of light. So another thing you can do, and it's actually something you can take advantage of, is to try to separate that difference between the background and the sample's broad fluorescence just by moving your filter higher up the spectrum to physically make a bigger difference between the sample that's fluorescing and then the background. And that's why you have the red goggles or the red filters. And different colored filters is to just sequentially move up to try to make that difference that the fluorescence excitation caused, and then exploit that difference by moving higher up through the filters. So luminol, that's what it was. So as I was describing, there's ways you can do it. You can chemically treat the sample. Another thing you can also do is try to cause, like what we've done here is using different filters, different light sources. Sometimes some backgrounds will fluoresce, while they fluoresce the same as the sample you're looking for, they fluoresce in different intensities. So you can try maybe bringing your lights closer, moving your lights further back. But overall, the main goal of these different techniques is just to cause the biggest difference between the sample and then the background that it's sitting on. And this is a really important part. And a lot of people will often ask us, what light and filter combination do you recommend? And what light and filter should we be using? Things like that. And the answer is that while mostly, many things fluoresce that you're interested in forensically, fluoresce with blue light at 455 with an orange filter or orange goggles, and that's a great place to start, that's definitely not the end-all be-all, because it really depends on what the sample is sitting on. Like if you've got fluorescent pink underwear, you may need to use a different light and filter combination than the ubiquitous white cotton t-shirt. So, moving on. So here's a good example, and this is my attempt to recreate an example from previous experience. So essentially what we have is we have a sample here, and that we've hit with 400 nanometer light, violet light, and we're getting a lot of background. We're getting a lot of green background. But what you can see is that we can still see some orange semen stains within all of this background. And so that's okay. That means there's something different going on. If you see a slight difference, that means you might be able to exploit that difference by trying a different filter. And so then what we've done is it's the exact same shirt with the exact same excitation. We've just chosen a filter, a red goggles, or red filter in the system, and just have moved up a higher area in the spectrum. And that has allowed us to see a lot more detail of these semen stains and reduce that background. The thing that the LSV does really well, we'll go a little bit through more, but it allows you to very easily change light and filter combinations. So you too can make your own Andy Warhol of a forensic example right here. And again, this didn't take very long. This was just using the white light, and then I tried the 455 blue, the violet, and it's very easy to quickly move through. So a really important topic to talk about when you're doing any ALS screening with the LSV, with a handheld ALS system, with pretty much anything, is the difficulty of distance, or it's the inverse square law. So essentially what happens is, as light is emitted from your source, it spreads out over distance. And when it hits the sample, the further away the sample is, there's exponentially less light hitting the sample. And that means you have exponentially less light to cause those molecules to get excited, and so you have exponentially less, really, detection capability. At the same side, it's actually also coming back at you too, because when you get those fluorescent stains to become excited and emit light, they also emit light back, and that also spreads out over distance. So really, it's actually a doubling of the inverse square law. And that's an important consideration to make when you're doing intense screening on difficult samples. This is something you're probably already familiar with. This picture is a good example of ALS screening. She has a handheld light source. She's got her goggles. So again, the light spreads out and hits the sample. Sample gets excited, and then it spreads out and comes back. What you have with the LSV, though, is you have a unique advantage in that you can get closer to the sample than you potentially can with just a handheld flashlight and goggles. Because the only way to really get your detector closer to the sample is to physically bring your face closer to the sample. So that's something to consider. So I should have addressed this in the beginning. So the neat thing with the YouTube streaming is everything is going to be recorded. And it's going to be recorded to this same link. So then you can share this link with anyone else who missed the training, or if you want to review it yourself, you certainly can. Difficulty distance, it spreads out over distance. Keep that in mind. And the LSV does allow you to bring your camera closer as well as your light sources closer. So I just put this little slide in to just think about it. We often, or sometimes we'll find people trying to screen with their LSV at distance. And while the LSV is very sensitive and is very capable of, that's how I took all those overviews, of moving the head out and taking those large overviews and seeing all those stains, your life is going to be so much easier in general if you just get that head a little bit lower. I did the math, and a meter of difference is about 8 times greater intensity loss. And so yeah, just keep that in mind. And here's my other slide, just telling you to get the head low when you're doing close-up screens, when you're really trying to find stuff. Another note on this is in the system software, there's something called a gain slider. I recommend you use that gain slider. And we'll go through that a little bit later, but that's just something to think about also. So the question comes up, if you want to get the head closer, how do you do it? Because you certainly can move the head closer, but you need the lenses to be able to have the right focal length. And so that's why we use close-up lenses. We call them diopters. They're used in cinematography, and the whole idea is it allows you to bring a lens closer to your sample. These are the same type of lenses that you can buy for like handheld DSLRs, things like that, such as the camera that we're working with right now. But what we've done is we've incorporated all of these close-up lenses, these chromatically corrected close-up lenses, into the head. So instead of having to, if you want to see something, instead of having to screw a big lens onto your camera, you can just click a button, and there's a cam system that'll rotate to the appropriate lens. And that's what the gearing system kind of looks like. So relative working distance, the bigger the lens, the closer you can get to the sample. So we put together this nice little chart. So your no diopter position is going to be near the ceiling. So that allows you to get those really large overviews. And then as you get closer, as you get a bigger number, you can work closer and closer to the sample. A quick note on that, the LSV2 system has what are called parfocal optics. And essentially all that means is when you zoom in and then focus, when you zoom out, the image will stay in focus. And that's a really good first off, what that does is make sure that you're in perfect focus. But second, it can also be a really helpful technique to use when you're working with these different working distances. Like if you're not sure if you're at the +2 or the +3, really all you need to do is just move the head down, let it sit there, zoom in, focus, and zoom out. And if the image is not in focus, what that means is you need to either change the close-up lens to a different one, or you just need to raise or decrease the height of the head just a smidge, just a skosh. Some other things to consider, just like any ALS system, is it also has to do a lot with your handling, your fabric handling. So things we've learned over the years are like denim. Denim is something that you should flip over. Oftentimes, denim is a fabric that has a lot of its own background fluorescence because of the two types of fibers, or maybe more, that have been woven together. But what's neat is denim can wick to the opposite side, and if you flip the fabric over, you can get that nice stain boundary. Also remembering to try to stretch it out, try different angles, things like that. One that I learned recently was about 3D fabrics, like knitted sweaters and woven things. One of our customers was telling us about just trying to flip it and try to image it, kind of, or look at it from the side. Just a quick note. Let's go back. And it's an important thing to talk about is the LSV system comes with a full set of goggles, and we recommend using them. You can definitely just use the LSV and use the whole system to screen, do all that. But we've seen a lot of our customers have success when they actually do both goggles and the system too, because that allows you to use it as a hands-free ALS system to help with your quick screen, and then you can also use it to document anything that you find. So food for thought is go ahead and feel free to use those goggles. Note on near infrared. So near infrared is a technique that you don't have with traditional ALS, but you do have with the LSV2 system. And it's pretty slick too. So near infrared, we can't see it, but the advantage is that there is a large contrast increase between blood stains and then dark fabrics, darker patterned fabrics. The way it works is based on absorption. So unlike fluorescence, where we're causing molecules to get excited and then emit light back, infrared is based on absorption. So what we see is actually differences in how the fabric absorbs infrared light than the substrate, or than the blood stain that's on it. So here's another diagram just kind of showing where in the spectrum we're working in. So you'll see that where the LSV operates is in what we call the near infrared as opposed to the far infrared. So it's not predator vision, it's the near infrared, and so that's 700 basically to 900 nanometers. So after visible, but before you get into the true infrared thermal camera type thing. What's kind of neat with near infrared is you can use it to detect, and as you can see in here, you can detect blood pooling under the surface of skin. Just kind of a fun trivia piece. That was actually our production manager's toe. The first thing I said to him was, "Are you okay?" And then the second thing I said to him is, "Can I take a picture of it?" He's good. He's still at Leeds too. So, but then you can also look at veniation too, which is kind of a neat thing. If you work with any coroner's offices, or I'm not too sure how many people do, but you can also use near infrared to do tattoo identification, regardless of skin pigmentation. So that's something definitely to look into if it ever comes up. Here's my schematic again. The idea is that we shine near infrared light down at the sample. Our shirt reflects back the infrared light, but our sample absorbs that infrared light. And so we then put a filter that blocks all the light other than the infrared. And this is actually what allows us to do infrared imaging in a brightly lit room. So here is the black Bloody Polo, which you may have seen before. And then here is that same black Bloody Polo just underneath near infrared. So all we've done is just changed our filter and changed our light to the near infrared filter and the near infrared light. And it's as simple as in the software, it's just clicking 2 buttons. And here again is an overview, just kind of showing that picture. This is actually really helpful if you're working with something that you think might have blood stains or anything like that. Near-infrared and overall screen can actually be a really good way to get started. So near-infrared also, we talked about pattern. Near-infrared also works on pattern. Fortunately for forensic examiners, a lot of dyes that are patterned that show up in visible light, because humans can't see visible light, don't necessarily show up in the infrared, because it's not been something dye manufacturers have been focused on. So here's what I would call a lot of pattern confusion. We've got a lot of things going on. You can maybe see there's a stain in the middle, but then when we switch over to infrared, I don't know how well it looks through the internet, but you can now detect 3 stains, whereas before you maybe could only detect that one really big stain. Here's another example, just showing, again, a lot of pattern. This is a printed pattern on felt, and so you can really easily see this blood stain show up. Near-infrared also works really well for gunshot residue, in that, so if your firearm sections ever need to do range determination, or if you ever get pulled into range determination, I'm not too sure why, but do know that near-infrared is also a really good way to highlight potential gunshot holes. So here we go from my colleague's Florida party shirt to his bullet-ridden Florida party shirt. So the thing about infrared, though, is while it works on a lot of fabrics and a lot of dyes, I would say it really only works about 75% of the time. And the reason for that is it's based on absorption differences. If you get a fabric that happens to absorb near-infrared light similarly to blood, you won't get a contrast increase. And that can be really frustrating. And so there's another technique that you can take advantage of, which is based on violet light. And the LSV has this ability. So violet light, or hemoglobin, has a peak absorption, or it has a peak of absorption at around 415 nanometers. And so the LSV is equipped with a 400 nanometer wavelength of light. And so the neat thing there is you can actually try to do this. And our customers that have done this, they've reported a 1:100 dilution sensitivity. And a quick note here is what I've personally anecdotally found is if it doesn't work in the near-infrared, I suggest trying the violet light, because I have seen it work on samples that don't work in near-infrared. So again, my hand-drawn drawing. Our violet light hits the sample absorbs, the shirt reflects back, and this says blocks visible light, and that's a typo. What we're doing here is we're actually just removing anything other than violet light, or anything other than visible. So here's an example. We have our torn pajama pant bottom, and it's covered in blood stains. You can kind of see those blood stains, and you might be indicated to go, hey, let's try infrared light. That seemed to work really well on that black Bloody Polo. And then you do it, and you don't get any contrast difference. And so this is actually a really good example of when to switch to violet. So we have, again, our white light sample, and then we switched over to violet light. And it can be kind of hard to see on a computer monitor, but there's a little bit more, I would say actually there's a lot more detail of these microspatter. Here's that same image just turned into grayscale, which I think is easier to look at. Human eye generally appears to work better on grayscale. And so you can really start to pick out some more of these fine blood details. And so then here's just that comparison image, where on the left side we have white light, and then on the right side we have that grayscale image adjusted for violet. This is also a good training example of the importance in starting in white light. What I always recommend people do when you start a new inspection, instead of going straight into fluorescence and then trying to find different light filter, trying to find all those things, just turn on the white lights and see what you see. because as in this case, while the violet light did make a big difference, you do see blood stains in white light. That's the violet light, and that's just reflected light, just like infrared. Oop. There's another technique that you can do where you use violet light to shine at the sample, and the blood absorbs, right? But you try to cause the background to fluoresce. And so that's actually a really powerful technique if you think about it, because you're doing an absorption technique paired with a fluorescence technique. And so you're basically potentially increasing your contrast detection methods by using both. I wrote here that it's a 1 to 100 dilution, but since I wrote this, we've actually had people report that using this technique, they've gotten to 1 to 200 dilutions if the fabric fluoresces from violet light. And that's actually really helpful on microspatter too. We were involved with a study where they were looking for, they had some camouflage, and they were trying to find light and filter combinations, ALS systems to highlight very, very small microspatter on camouflage. And what was really cool is using this technique, you were able to screen it, find it, and then document it. And that was not something that they had expected or hadn't seen before, which was kind of neat. I unfortunately can't share those pictures, but I can talk about them. So yeah. So here's our violet reflected light fluorescence enhancement. So the idea is I shine our violet light at the sample. The background fluoresces. It gets excited and glows. It emits light, orange light back. And then our blood stain absorbs that light. And so effectively what it's going to do is show up as a shadow on a well-illuminated background once we've put our filter in, our orange filter in. So this can be a helpful technique for camouflage, but it can also be a helpful technique for a lot of navy knit fabrics. So like balaclavas are what the Canadians call them, or ski masks. You can also just any of those navy fabrics, I have seen some background fluorescence. So I would suggest trying this technique. Another one that can be helpful too is not just using that orange filter, but trying a red filter. Because our red filter on the LSV system lets through some infrared light, and you can actually get a pairing. And so that's something to consider trying for navy or dark knit fabrics. And just kind of give you guys a quick overview back to the system and just walk through some of the controls and how to move things, that type of thing. Because I totally get it. If you've never been trained on it, or if it's just sitting in your lab, it is kind of intimidating looking about where do you even begin using the system. But the good news is it is very easy to use once you know how to use it. The LSV head is located here. It's essentially divided up, as you can see in our PowerPoint presentation. You've got your filter turret here, and that's loaded with 5 barrier filters. It's got the clear filter, a 550 orange filter. It's kind of a green, like a yellow-orange filter, a dark orange filter at 570, a red filter, and then you've also got your near-infrared filter. And then you also have your wavelengths here. Something that I'll recommend doing is you might be inclined to try to adjust your light. I didn't even do it how I was trying to demonstrate. You might be inclined to adjust your light without holding on to the head or trying to adjust both lights simultaneously. But what I recommend doing is having a hand on the head itself and then adjusting each light independently, and so that the lights are overlapped. And that'll help you a lot too. Another part that is really important to talk about are the pivot points on the arm. So we've got 2 pivot points. We've got one, as you can see in the diagram, and as you can see here, we've got a pivot point there, and we've got a pivot point near the column. And they have the idea is you want them loose enough that you can freely float your arm and move over your work surface, but you don't want them so loose that the arm just wanders away on you. So if you see your arm starting to wander, these are just friction. The idea is to just add a little bit of friction to both of those joints so your arm doesn't move. Another really important one to talk about is located here. This is our tension adjustment. Not too sure how well everybody can see, so maybe what I'll do is we'll flip over just to the camera. Yeah. So this is the tension adjustment for the arm. And the concept of righty-tighty, lefty-loosey does not apply with this arm. And that's because it's a double, I think it's a double spring, or it's either a double piston system. And it's just adjusting the load of each piston. So the idea is you want to move it and see where if it stays. And if it doesn't, you want to find there's going to be a place where you can't adjust it. There's too much tension loaded up on it. So what you want to do is move it to a place where you can, make your adjustment, and then test it. And see if it stays in the position that you want it to stay. Sometimes you might come into your lab, and if it hasn't been used in a while, you might find that the arm is fully down and doesn't hold position. That's okay. It just means you need to do that rebalancing. And so just go ahead and lift it up, find the place that you can make that adjustment, Like here's a really bad adjustment, so now I have it. I let go, it's not staying in position. So then I can come in, find where I can adjust, and then kind of see where it goes. We also have a YouTube training video on that as well, if you guys want to watch it. Going back to the head, how the head tips, tilts, and rotates. The idea here is that the LSV, you can use it just like it is, but if you have a sample that you want to come in from the side, you can certainly do that. It's got a series of, let's just go make sure I'm on the right one. There we go. There we go. It's got a series of locks that allow you to tip, tilt, and rotate. So the whole idea is that you can very easily maneuver into position. So to do what I would call a yaw, which is this type of motion, there's just a simple lever located right here. I'm going to go ahead and actually bring this up. So to do a yaw, there's a simple lever located on the opposite side, and that will let you rotate the whole system. If you want to do a pitch maneuver, there's just a simple little lock mechanism located right here that you can pull out and loosen to the side, and then you can actually tip the whole head. And then the last one to point out is back here, and there'll be some PowerPoint slides where you'll have close-ups in a second, that you just pull out and disengage, and now you can actually roll the whole system. So the idea is between using that tip, tilt, and roll, or yaw, pitch, and roll, instead of having to, if you want to document something, instead of having to try to prop it up, you can just get the right angles that you need. So then these are just some close-up pictures showing you exactly how to disengage these pins. So this is our pitch, and this is that roll pin. So you just pull that out, and then you can roll the whole system side to side. And then, yeah, you can go multiple directions. The idea with the LSV system is just, it's another ALS system. It's using wavelengths of light to set up an excitation and emission difference that then you can exploit with filters. And it's all about trying to pick which light and filter works for a particular background. In the Leeds Vision software, you can make presets. You can do things like that to make your life easier. But again, really, most of the time, I suspect you're going to start with your blue light, your orange filter, and then go from there. You also have near infrared, which is what the LSV is also very good at. So you have the ability to do blood and dark, reflected violet light, and then you also have fluorescence with violet light, which is another useful technique. A big one is always to try to work close to your sample as much as you can, particularly when you're doing close-up screening. And then if you need to do those larger overviews, you can, but it's a lot better to start close. I always recommend also starting in white light and then going from there. And yeah, use different techniques. If you have something that you suspect and you can't necessarily find it just on your first pass with orange and orange, or a blue and orange, you can then try different things. Also, please feel free to always contact us. Let us know if you have any questions, if you're running into difficulty or just want help in general with your system. So, for now, Thank you. Any questions? And when we come back, we're going to have it slightly set up differently. So you'll be able to see the monitor. We'll have the camera over my shoulder. You can see the monitor. And then we can go through and discuss some of the tools that are built into the software about how to change light, how to change filter, just how to maneuver the whole system as a whole. We're now back. We're now in a dark room with the Leeds Vision software. So hopefully you guys can see things that are looking okay. Yeah, so this is your software layout of the Leeds Vision software. To turn your vision system on, it's very straightforward. Just make sure that that big green power button that's in the base of your system is turned on, and you just launch the software. If you start your computer, if you start the computer that's built into the base of the system and turn the power on to that big green button, I suggest giving it maybe 5 minutes after the computer's loaded before you launch the software. And that's just to give it time for the camera to talk to the computer. You can certainly launch it before that link has been established, but what you'll see is an error message, and it will take a loading period of time while it figures things out. Quick note to talk about is we want to make sure that you're on Leeds Vision 4.4. And that's an important thing because Leeds Vision 4.4 or anything greater has a lot of new error codes, a lot of new capability built into the system. We're also now Windows 10 compatible, and that's an important thing I know for a lot of labs, as Windows 7 is no longer supported. So just if you go to the About tab and see your Leeds Vision software version, let us know if it's not the most recent up-to-date version, and we can send you a copy. But it should be at least 4.4. So yeah, this is your live window. In general, all of your controls are loaded on the right-hand side. So you've got your image capture button here, and we're kind of like Photoshop or Internet Explorer in that it's a tab-based system. So each time you hit capture, it just keeps taking pictures and it stacks them up along the top. There is no limit to the number of pictures you can capture. However, everything is going into the RAM. So what I generally recommend is maybe after 20 pictures, maybe 15 pictures, start considering which pictures you want to save, and then you can keep moving on. Going back to, again, also on the captured images, you'll see that our lens controls, on live image, we have all these lens controls. But when you go to a captured picture, you no longer have those lens controls. And they've been replaced with the image data. So this shows exactly what filter was used, what light source was used. Cam is such that the entire screen is blurry. Okay, got it. Got it, guys. Let's see what I can do here. Unfortunately, we do not have an aperture on this camera. So I think that's about as good as I'm going to get it. General layout, metadata, and that's where that is loaded. You probably can't see it, but do know that when you get to your LSV system, you have your metadata is all loaded on that left side. I'm going to see if I actually move this up and sample a different area. So that shows your metadata. That shows how you've captured things. When you go back to your live image, this is your controls. You have your brightness slider for your camera. Essentially, as you increase the brightness slider, the image gets brighter. As you decrease the brightness slider, it gets darker. You have this gain slider, which I'll go over in a little bit. And then you have your lens controls. And just like what I had talked about, these are the lens controls. And just like what I had talked about before, the idea with the LSV is that it's a parfocal system, meaning that when you zoom in, and this fabric has a lot of three-dimensionality to it, so I'm going to actually stretch it flat. When you zoom in and then focus, and you can use the scroll wheel on your mouse to do really fine steps, or you can use these plus or minus buttons on either side to do bigger steps. But the idea is when you focus and then zoom out, the image is going to stay in focus. And that's a really, really helpful thing. Or turn on the room light. Yeah, let's go do that. 1 second, guys. So yeah, that's the idea with the focus, aperture, and zoom, or the focus and zoom, is that ability to zoom. We had talked about close-up lenses, those diopters, that big cam system, and that's what these diopter numbers are for. Again, the idea is if you're on the wrong diopter number, you won't be able to zoom in, focus, and then zoom back out. Instead, what you'll see is an out of focus image. And so if that happens, then you just want to raise the head up a little bit or lower it or change to a different diopter. You'll also see if you mouse over them, the diopter lenses will display their rough working distances in whatever your display units are. So in this case, I'm in millimeters. So if I would change it to inches, the diopter lenses will show their rough working distances, which can be helpful. Underneath that, you've got your presets. And these are, Leeds loads presets based on experience, but you can make your own presets. And in fact, there is no limit to the number of different customized presets that you can make. So if you find the perfect light and filter combination for purple underwear, very specific, I know, but apparently purple is a hard color to screen. You can just hit this save button. It'll pop up a window, and then you can type in whatever you would want to call it, so purple underwear or otherwise. You'll also see, and it's probably hard to see on your screens right now, but there's a lot of different little selections for what you would want to save with the preset. And you can be as specific as just the light and the filter, or you can choose everything, including the diopter lens, the focus, all of those. I don't know how much you're going to be using presets, but the big one is the light and filter combinations down here. So if you click here, you can see all of your filters. So these are effectively your goggles. And as you change them, it'll update to the appropriate filter. Similarly, your lights are loaded right here. You'll see there's a pause while the auto exposure adjusts. You'll see your lights are loaded here, and then you have your 7 wavelengths to choose from, ranging from the ultraviolet at 365, which is above DNA nicking. So it's UV, but it's a safer UV. We still recommend, though, wearing goggles and gloves if you're using it. But then, yeah, you have your violet, your blues, your greens. So you can choose from there, including your near infrared. We've labeled it IR, but it's technically near infrared. And then also, one of our customers asked for, actually, I believe it was Libby Schreiber, asked for the ability to turn on or off the lights. So if you just want to image using ambient room lighting, you can absolutely do that. So just for an example, I'm going to go to our blue light. So I'm going to choose our blue light. I'm going to choose our orange filter at 550. So this is what I would say is pretty typical of your screening setup. Blue light, orange goggles. And I'm going to turn off the lights. 1 second. So the advantage is, because I did that porfocality test, I zoomed in and focused. Now when I've gone into fluorescence, everything's in focus. There's none of that delay of trying to figure out what's in focus or not. What you'll see is this is where gain comes into play when you're doing fluorescence screening. Again, I realize it's probably out of focus, but there is a gain slider here. And as you increase your gain slider, it makes the camera more sensitive to light. And there's a little bit more digital noise, but now it's a lot faster. So when I move the head around, I'm actually getting a real-time video feed as opposed to having to wait for my camera to catch up to me. So what I generally recommend doing is having the gain boosted when you're working with samples, have the head close, and then what you find what you're looking for, you can move over here into these Siemens stains, you can zoom in. When you find what you're looking for, then you can go ahead and just bring that gain back down, and then the camera will use where the brightness slider is to recalculate the auto exposure. And then you're good. And that's basically it. So you can try different wavelengths. This is blue, we can try violet, trying to cause a difference to exploit. In this case, the background's now fluorescing green, so that's not so helpful. But this is where I can use that light and filter. So maybe instead of our orange filter, I'll go to my dark orange filter. And still not so helpful, so maybe my red filter. Okay, well clearly it's not going to work. This light and filter combination is not good here. So this is why I would go back to my blue light. While you're working you can be capturing pictures. So I could be hitting this capture button up here. We could go back to our orange light, and I could hit the capture button up here as well. And what you'll see is it's made those captures up along the top as a tab system. So now if I click on it, I can see the picture, and I can see all the metadata of how that picture was captured. You have the ability to compare images side by side by clicking on a captured picture, going to Tools, Compare To, and then choosing the previously captured picture. You can then export this, you can save it as this, you can do that. You also have the ability to digitally, if you link the two pictures together, you can digitally zoom in on one side, and it will digitally zoom in on the other side. So there's a lot of tools to play with. I suggest taking a look at them, familiarizing yourself, see how that works. If you have questions, we also have more training videos specific on this. Left click zooms in, right click zooms out. When you're done, before you're done, let's say you wanted to come in and you wanted to do some annotations, you would choose the polygon tool, and then it would allow you to draw boxes around things that you're wanting to highlight or show interest in. And so then you can see it's drawn on both sides. To change the colors, simply select the polygon that you're interested in, go to Properties, and then now you can change the line thickness, you can change the color, and you can do them independently for both images. So these are some of the annotation tools that the system has. It also has calibrated measurement capability too, that we have some other videos on that we don't need to go into unless you'd like to. But I suggest just taking a look at those. Essentially, the one thing to talk about the calibrated measurement, I'll just make a quick note on it, is when you take your picture, if you want to do measurement, make sure you have a ruler or something in your picture that you can use as a reference. Something that's new to the most recent version of Leeds Vision software is the ability to do automatic saving when you capture. And the way you do that is you go to Tools and do Automatic Naming. And the automatic naming screen, and I'm pretty sure you can't see it so well, but essentially you direct it to a location on your computer, and then it's got a key that then you can set up your naming convention. So if you wanted to call it case number image number 1, case number image number 2, you can do that. You can also have it pull in metadata, for example, date or timestamps. And then you would click this autosave on capture. That can be a really helpful tool if you just want to take a lot of pictures really quickly and then just keep moving on casework. Another tool that's new to the software in our more recent versions is the ability to export all of the pictures you've captured or save all of the pictures you've captured. And that's where you go to File, Export All, or Save All. So those are some features just to talk about. Really what it comes down to is, I think, just playing with it. Get used to the LSV system, try it out. The biggest thing I would recommend doing is just working with the head close to the sample and then remembering to use your gain slider. Because you'll note when I'm at a low gain setting, my frame rate really isn't that usable. And if you're working on a very difficult sample, this could be very challenging. So what I would recommend doing is increasing the gain, keep that head close, and then make sure you try it out. So there is a small time delay between what I've talked about and the questions. And I think your question, Libby's question, was about the auto-saving. I'm not too sure. But yes. So this auto-save is designed so once it's turned on, it'll continue being left on. So if you go to File, and do the tools automatic naming. Once you have autosave on capture will remain turned on until you've turned it off. And another quick point is the autosave setup only saves as LVI files. It doesn't save them as TIFFs or JPEGs. So if you're using the auto-saving feature, once you've taken all of your pictures, what we recommend doing is going to the export all function, and then it'll export them. And another thing that I didn't mention also with the newest version of our software is the software knows how you've named your files. So when you go to export a file, you won't have to recreate your name. It's a silly thing. I think every Windows program out there does it. It wasn't something we had done, but now we do. Quick note also, just while I'm thinking about it, you have for image data, anytime you open a Leeds Vision file, Leeds Vision operates what called LVI files. And every time you open one of our native LVI files, it'll load the image metadata. And it's not just loading it, but it will allow you to reapply it. So let's say you're working on a case and you need to take some pictures, and then you go to lunch, and then you come back and want to pick up where you've left off, but the system's turned off. You can just open one of your previously captured pictures if you saved it as an LVI, and then just hit the Apply Settings button. And then the system will go back to all of those settings that you had been using before you interrupted your work. Hopefully this is helpful. Any other further questions so far? In the normal workshop flow, this is where I'd be picking victims and putting them on the system and having them drive it. But it's a little harder to do remotely. That is a great question about DNA degradation. So the LSV systems, the short answer is not if you use violet, blue, green. If you use all the wavelengths other than ultraviolet, you're good to go. And that's because the LSV systems wavelengths are very specific. We're using LEDs that are very specific to the wavelength labeled here from maybe plus or minus 5 to 15 nanometers. And that we've had, I think it was Kansas, who was it? Kansas City Police Department early on did a validation where they were looking for dropout, and they didn't find any significant dropout with the system. So the short answer is everything other than 365 is fine. Even 365 is probably okay. And because it's actually above that threshold where it will cause nicking of DNA. And the longer answer is it's because we use wavelengths that are very specific, and we're not going into that ultraviolet part of the spectrum, which causes a lot more damage to DNA. And I realize I have this open, but you probably can't see it. Thank you, James. Yeah, that's another good question. There is no software licensing restrictions. You can install Leeds Vision software on as many computers as you'd like. And the idea there is exactly what you suggested, is that you can just quickly take your pictures in the laboratory with the LSV and then take those pictures back to your desk and then do all of your annotations, all of your notes directly on those images while being able to reference the metadata. We've been really intentional about keeping it like that as license-free. Yeah, it's something that we tried, replying to James, yeah, it's something that we've been really focused on. We want, so the Leeds, there is a catch though, there's a slight catch, is that Leeds Vision software, the Leeds Vision, will only open LVI files. And so that's the slight catch there. And we do that in part because then we know anytime Leeds Vision is being used, it's in support of a Leeds Vision system. And so yeah, I think if you're going to be saving your pictures or wanting to work at your desk with those pictures, just to save them as LVIs and you'll be good to go. So, excuse me, you can certainly email me, anybody who wants to. My email is the letter J, Kurth, at leedsmicro.com. If you have questions or want anything further or want a download link to the software, Libby's question. Yes, we have definitely brainstormed that. It is something that we have designs for, but it's not something we've implemented yet. If you guys want that, that's definitely something that we can prioritize for the locking system. The software cannot do grayscale at this point in time. It's something that's on our wish list. The grayscale is, I think, really, as I showed in the presentation, I think the grayscale is really beneficial for working with that violet light. So that's high on my wish list to get it added. One of the nice things about doing our own software design is you get to put in whatever you want, but the downside is you have to pick those features. For now, if you are interested in doing grayscale, the way I prepared that particular picture was using Windows Paint and just converting to grayscale. I know it's not ideal, but that is our current solution to going grayscale. You know what? In general, I recommend trying it out. Keep the head close, turn up the gain, and use that parfocal zoom optic. I really can't sell that enough. It's about, when in doubt, zoom in. And you can see how my zoom's slow here. It's because my gain's low, so I'm going to increase my gain. I'm going to zoom in and then focus, and then zoom out. And I think that'll make just using the system a lot more approachable and a lot easier. Thank you, Libby. We appreciate it. We're more than happy to do these type of trainings. You know, COVID's kind of caught everybody a little bit wrong-footed, and I'm really hopeful that we can continue to do these type of training things for anybody who's interested. So actually, on that note, if there's anything else that anybody is interested in, would like to see more of, would like more topical training YouTube sessions, please feel free to let us know, and we can set it up. But I think, unless there's any more, okay, I think that's it. So thanks for watching, guys. This link will stay active, so even after the end of the stream, you can rewatch it. What I'll be doing is just going through and trimming out some of the technical, difficult sections. But yeah, thanks for watching, and please use that system. Call us if you ever have any questions. Thank you much.